In the sequence above, each term after the first term is equal to the preceding term plus the constant c. If a1 plus a3 plus a5 equals 27, what is the value of a2 plus a4? So my mind at first goes to the method of we've got to, try and reduce the number of unknowns, at least by a little bit. Right now what we've got is this statement, a1 plus a3 plus a5 equals 27. And I'm wondering, can we rewrite this so that there are less variables? We got these three things that are unknown. It would be great if we could reduce that by a certain number. So turns out we can do that, because one of the things that's true, based on this statement here, the fact that each term after the first term is equal to the preceding term plus the constant c, you could say things like, well, the first term is equal to the first term, and that the second term is equal to the first term plus that constant c. And you could say that the third term is equal to the first term plus c, which is the previous term, which is a2, plus another c, right, which is probably better written as plus 2 c's. And that the fourth term is the first term plus 3 c's, and that the fifth term is the first one and the 4 c's. And I could go on, but that's the general pattern. And with that in mind, it becomes possible to rewrite this slightly simpler. We could replace, well, we can't really replace a1 with anything. a1 is a1, but we do know that a3 is a1 plus 2 c's. And we do know that a5 is a1 plus 4 c's. And we know that all these things added together are equal to 27. Now let me combine some like terms here. I got some a's and I got some c's. So we have this fact that 3a1 plus 6c is equal to 27. Now, it's not going to be one of these simultaneous equations things where we can, have two equations and two unknowns and solve it. But having this reduced from 3 variables to 2 variables is definitely helpful, and that's one of the things you want to apply on exams like this. It's a really common strategy. So let's see what we can do with the other statement, or rather the other fortunate thing we have to deal with here, this fact that a2 plus a4 equals something, right? It's definitely something we have to deal with. It's not a statement, it's not really an equation, because we can't really use it in tandem with this. We don't know what it's equal to, it's not complete. But it can be rewritten by similar methods here. Like we could rewrite a2 probably as a1 plus c. And we could rewrite a4 as a1 and 3 c's. We still wouldn't know what it's equal to, but we have sort of unified the thinking of this equation with this equation. And I'm just assuming that this is going to be helpful. And if I simplify this, I have 2a1 and 4 c's, and I don't know what it's equal to. So finally, we've got these two statements. We've got 3a1 plus 6c is equal to 27. And we've got this statement that references the same variables, 2a1 plus 4c, and we'd like to know what this is equal to. At this point, you hope that these two are related somehow, that maybe one is a factor of the other. And if indeed this is a fair test, GRE, GMAT, that sort of thing, this will be the case. There's no other way to do it. You could simplify this by factoring out a 3, and you'd have a1 plus 2c is equal to 9. And now what we're going to do is we're going to look at this equation relative to this one. How can we get from here to here? Well, if you look really closely, and you look specifically at this part of it, a1 plus 2c, you can relate it to 2a1 plus 4c by a factor of 2. This is no longer a question mark. You now know that you can do this by multiplying by 2. This equation is half of this equation, which means if a1 plus 2c equals 9, then exactly 2 times that, again, you can rewrite this even as 2a1 plus 2c. You can clearly see that the difference between these two things is a factor of 4. Then this thing would be equal to 2 times 9. So 2a1 plus 4c is equal to 18. But remember, 2a1 plus 4c was a rewriting of a2 plus a4. Therefore, a2 and a4 is equal to 18.